Welcome to the second half of chapter 7. So recall, we've already completed the first half of 7. We were talking about exponential equations. Now we're going to transition thought and we're going to talk about logarithms. Now, logarithms basically are a way of solving for the exponent of an exponential problem. So we're going to be taking a look at things like this. Investigating how do we solve for exponents. That's what a log is really doing. So I think in this case, you'd find it pretty easy to see that x is going to be 2. 2 to the second gives me 4. Or x would equal 1 here, 2 to the first. 0. A negative exponent sends it to the bottom. So here, basically, what a log is going to do is it's going to help us solve that for not so easy cases, okay? Because what if I gave you something like this? 2 to the x equals 3. Well, now it's not going to be a nice number. And that's ultimately what we're going to learn to use logarithms for. But of course, we're going to begin with simpler cases. We're going to begin with the basics and then work up to how can we use logs to solve those more difficult cases. So let's take a closer look. So here's our first example. Now really, what that's saying is the same as this, okay? That's how you would actually solve that problem, okay? Log base 2 of 4 is going to equal x. Now let's think about what that's saying. So what it's saying is 2 to what power gives me 4. And again, you guys know that that's 2. For more complicated situations, this is going to be the computation that we use to find those more complex cases. So generically, whenever you see a logarithm, okay, whenever you see it, basically it's asking what power of b will give you y. So b to what power gives you y. Okay, and it's read with log base b of y. That's how you read it. And b must be positive. It must be greater than 0, but it can't be 1. And we're going to discuss that more later. So a logarithmic form of an equation, okay, looks like this. And again, is doing exactly what I was just saying. To transform it is basically saying b to the x power gives you y. Now, my high school teacher, even though this sounds really corny, really cheesy, this is what my teacher always said, okay? He called this Mr. Loopy because you really loop around. You start at the base and say b to the x is y. And you can see that written over here too, okay? But essentially that's what it is. So he called that Mr. Loopy because you loop around. B to the x gives you y. So when you're evaluating a logarithm, you're finding what exponent can you put in that base to give you that main number, okay? That's all a logarithm really is. So let's talk about transforming these, writing them in its alternative form, because every logarithm can be written as an exponent. Every exponent can be written as a logarithm. So here, this is very straightforward. This is exactly what Mr. Loopy says. You loop around. 3 to the 4th power is 81. That's all you have to do when you're trying to write it as an exponent. 3 to the negative 2 equals 1/9. 25 to the 1/2 equals 5. So again, if you just keep in mind, again, I know it's cheesy, but if I remember 10 years later, it must have worked when I was explained to it that way. So just think Mr. Loopy, you're looping around. Now, what about putting it back in logarithmic form? So, what I want you to notice, here I'll actually go back up, is the base of the logarithm is the base of the exponent. So that's going to be the first thing to note, and I laid that out right there for you. The base of the exponent is also the base of the logarithm, and the exponent is the solution. remember we're using logarithms to find exponents. So the exponent is going to end up being the solution in the end. So that's how I always write them. Okay? Log base, again, that base is the same as the base of the exponent. And the exponent is the answer. So then I just fill in that 100. And again, you can always check it to make sure that you did it right. 10 to the 2 equals 100. Okay? So that's how I would do it in this direction. So again, let's try it again. So the base of the exponent is the base of the logarithm. The exponent is the answer. And then I just fill in the other number. And let's check to make sure we did it right. Let's use Mr. Loopy. 3 to the 0 equals 1. The base of my exponent is the base of my logarithm. The exponent is the answer. And then I fill in the rest. So 2 to the negative 3 equals 1/8. It worked out. Base of the logarithm, the exponent is the answer, and then I fill in the other number. So 64 to the 1/2 equals 8. So it's very important that you're able to go between these forms, okay? Now let's dive into the real meat of today. So the real meat of today is looking at how can we evaluate logarithms. Okay, so here, if I show you something like this, just log base 5 of 125. And I ask you to evaluate that, okay? I want to know what that equals. That is a number. And remember, the number that it is saying 5 to what power is 125. Now, to help you, what I'm going to have you do is set it equal to a variable, okay? Because that's going to help you rewrite it. So whenever you're asked to evaluate, I'm going to have you set it equal to a variable and use Mr. Loopy on it. 5 to the x equals 125. Okay? Because you guys are much more comfortable in exponential form. So that's how we're going to start solving these. Now, 125. Now, I'm going to do some manipulating. I need that to have the same base as that side. Well, 125 is 5 to the 3rd power. Okay? So, what that means, because I can rewrite it like that, well, if I can write it in the same base, that means my exponents must be the same. So that must mean that this is 3. So that logarithm equals 3. 5 to the 3rd power gives me that 125. Okay, so that's all we're doing. So the rest of this day is mainly about that, okay, evaluating those logarithms. So this second one, again, the goal is 2 to what power gives me 32. So to help you see that, I'm going to set it like this so I can physically see 2 to what power is giving me that 32. That's what the logarithm is finding. Okay, so now we just think, how can we rewrite 32 to be a power of 2? We need to rewrite this. Well, as you're searching, maybe you don't know, so maybe you try 2 to the 3rd. Well, that's only 8. 2 to the 4th, that's 16. You come to 2 to the 5th as you're searching through your calculator. Okay, 2 to the 5th is 32. So I need to rewrite it so it has that same base. Because now that it has that same base, now I can say that they're equal. And so that logarithm equals 5. Okay, let's try one last easy example. Again, to help you, I'm going to tell you, set it equal to some variables so you can see what you're doing. What you're looking for is 3 to what power gives you 243. That's how you're going to evaluate this logarithm. Well, again, maybe you don't know off the top of your head, but you know you need to rewrite this as a power of 3. 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth, that's where you get to see 243. So what does that mean? Well, that means that logarithm equals 5. That's the power of 3 that gives you 243. So those are the most basic examples, okay? Those I think you can probably do pretty easily once you realize what you're doing. Now, the real meat of this comes into when you start getting things like this, okay? So, same idea. If you're evaluating a logarithm, what you're looking for is 2 to what power gives me that 1/4. Now, here's where some manipulation comes in, all right? This one is not as obvious to see. So I've given you some hints. I've broken this down. So remember, fractions are going to mean a negative exponent. So I can rewrite this. This 4 is the same thing as 4 to the negative 1. Okay? So that's going to be my first step. Now, 4 is 2 squared. Okay? So, to rewrite this with a base of 2, I need to have a 2 up there. Okay? So, now I have what I need. Okay? Now, I have that logarithm is going to be a negative 2. Now, what about this one? Well, this one is the same story, okay? So 3 to the x equals 1 over 27. All right, so let's bring that negative 27 up, all right? Now, 27 is 3 to the third, okay? However, because of that negative, it's not 3 to the third, it's going to be 3 to the negative third because we already have that negative up there, okay? So, looking at this, now that I rewrote it in that base, now I know that that exponent is negative 3. 3 to the negative 3 power gives me 1 over 27. Okay, so just remember that if you need to ever move its location in a fraction to bring it up or send it down, remember you just simply make a negative there. Now, what if they're both fractions? Well, same thing. You're still looking for 1/2 to what power gives you that 1/8. That's what Mr. Loopy says to do. All right, well, here I don't need to move the 8 up because the 1/2 is already written as a fraction. So this time I'm not going to worry about moving it around. What I'm really going to worry about is the fact that 8 is 2 cubed. So 1/2 is, so 1/8 is 1/2 cubed. Okay, so here I'm not going to bother moving it around because they're both fractions already. So I can simply say that this time is going to give me 3. What about this one? So I have 1/5 to the x. I need to know what power of 1/5 gives me 1 over 25. All right, well, again, since both of them are fractions, I'm not going to bother moving that 25 up. What I'm going to notice is 25 is 5 squared. Okay, so 5 squared gives me 25. 1/5 squared gives me the 1 over 25. So ultimately, what does that mean? Well, that means that that logarithm is 2. That's the exponent I can put on 1/5 to give me 1 over 25. All right, what about this? So now when I do this, what power of 81 gives me 9? So when I rewrite this one, so now I need to recognize something different. Okay, so here to rewrite this as 81, well, 9 is 81 to the 1/2 power. Okay, so here you have a different type of manipulation going on. Okay, to get 9 to be 81, well, 9 is 81 to the 1/2 power. It's the square root of 81. So to rewrite it, I need 81 to the 1/2 power. That's what 9 is. So here, this logarithm is going to be 1/2. So all this is a lot of power manipulation. Okay. Now, what about this one? So here I introduce a new idea. So 49 to what power gives me 1/7? Okay, well, 49 to what power gives me 1/7? Well, here, my first dilemma is I need that 7 up top, okay? So I need to put a negative exponent on it to bring it up top because the base of my exponent is simply a whole number. It's not a fraction. Now, how can I rewrite 7 as 49? Well, 7 is the square root of 49. So what that means is I need to take, to rewrite this in terms of 49, 49 to the 1/2 gives me 7. Okay, so to rewrite it in this case again, because I have to rewrite it in terms of 49, well, the square root of 49 is what 7 is. So here, since I already had the negative, notice my answer has the negative as well. So x is negative 1/2. So whenever you have to deal with square rooting, remember square rooting is really just the 1/2 power. Okay? Oh, I'm sorry. All right, and now looking at these. Now sometimes when you rewrite them, 4 to the x equals 32. So here, 32 is not a power of 4. So sometimes when you hit a situation like this, sometimes you have to rewrite both. 2 or 4 is 2 squared. 32 is 2 to the 5th power. Okay, so sometimes you're going to have to rewrite both of them and solve from there. So this time when I set my exponents equal, I get 4 to the 5/2 power gives me 32. What about this one? 9 to the x. So I'm trying to find what power of 9 gives me 27. Well, again, there's no power of 9 that gives me 27. So I need to rewrite this. 3 squared gives me 9, and 3 to the 3rd gives me 27. So this time, since the exponents have to be the same now, I get 3/2. And we still have a couple more that we're going to do. So other various situations. So here, y to what power gives me y to the fifth? Well, if y to the x gives me y to the fifth, then it's just going to be 5. That's actually a very common thing, okay? Whenever you have a base and then it to some power, the answer is going to be that power because y to the fifth power obviously gives you y to the fifth. So that one is actually a property that's going to keep coming back, okay? And what about this one? 6 to what power gives me 1? Well, here hopefully you can recognize that anything to the 0 power is how you get 1. So that's going to be 0. And this one, you actually can't even do, okay? You can't do it if you have a negative number in there. So that is one restriction, okay? You have to absolutely have a positive number that is not 1. Or sorry, that can be 1, this can't. But the number that you're taking must be positive. So another rule to talk about is the common logarithm. So a common logarithm is a logarithm with base 10. So you can write a common logarithm log base 10 of x simply as log of x without having to show that 10. So really what this is just an easier way of saying log base 10 of 100. So essentially asking 10 to what power gives you 100? Well, I think pretty quickly, you'll see 10 to the second power is what gives you 10. Okay? And what about this one? Oh. What power of 10 gives you 1/10? 10 to what power gives you 1/10? Well, to move it up, you have to put a negative on it. So I think you'll pretty quickly see again, in order to move that fraction around, you have to have a negative there. So 10 to the negative 1 gives you that 1/10. All right, one last thing to work through. So one good example of what uses a logarithmic scale is the Richter scale, which is used to measure earthquakes, okay? The energy of an earthquake, that's how it's measured. So let's take a look at this. So in December 2004, an earthquake with magnitude 9.3 on the Richter scale hit off the northwest coast of Sumatra. The diagram shows the magnitude of an earthquake that hit Sumatra in March 2005. That formula compares the intensity levels of the earthquakes, where I is the intensity, with the magnitude on the Richter scale. So we want to know is how many times more intense was the December earthquake than the March earthquake. All right, so in December, the earthquake had a magnitude of 9.3. And in March, it had 8.7. That's what that's telling us right there. Okay, so that's a difference of 0.6, which you probably think sounds really, really tiny. Okay, so you're probably not thinking much of it. However, let's think about what that really means. Okay, so remember, this is secretly a log base 10. So if I rewrite this, 10 to the 0.6 power gives me this. So I want to know how many times stronger that earthquake was. Well, that's what this is telling me. How many times stronger is this fraction right here? So 10 to the 0.6 power is 3.98. So what it's telling me is that that March earthquake is almost 4 times stronger than the December one. Okay, so looking at that, a small change on the Richter scale is actually a super intense difference, 4 times the destructive power in that second earthquake. All right, so there's a lot of stuff that we covered here today. This is kind of a beastly section. So don't worry, we are going to go through a lot more in class of examples of this so you guys can kind of get this straight and figure all of this out. So, but I do want you to summarize all those little techniques. And I commented on a lot of them for you. For example, when do you get a negative for a logarithm? When do you need a 1/2 in your logarithm? So all those little tricks that I talked about, I want you to go through. And then again, don't panic. We're going to do a lot of examples in class to really help solidify these ideas of logarithms. All right, so thank you so much for joining me. And again, don't panic. We are going to come back to this a lot to review some more.